All right, what's up, everybody? We have Unit 3, review sheet number 2. This is on equations and slope-intercept. So I've worked out a couple of these problems for you. This way you can get a little bit better explanation for the Google form. If you notice, a lot of them say just, if you get it wrong, it says see the attachment below. I wasn't able to upload the picture file, but I figured I'd just do the video for it so you can see everything on one sheet. So here we go. Number one, you just want to isolate that variable g, use inverse operations, solve it, and you're going to get one solution. So the one solution is g equals 8, which is letter B, choice B. Then head over into number two. Number two, you see you have parentheses here at the top. To get rid of that, you want to use distributive property and multiply. So when it comes out, then you'll have these two terms here in blue. You can combine those like terms, those constants, and now you're going to get on the left-hand side 6w minus 14. On the right side, just bring down 6w plus 7, and you'll notice I put a note here in black on both sides. When an equation, or two equations, have the same slope, so in this case, 6, which is their coefficient, but they have different y-intercepts, or constants, which you see with the blue arrow. So I have negative 14 here on the left, I have positive 7 on the right. So anytime you run into this situation, it's going to have no solution because you have the same slope or the same pattern, same coefficient, but you have different starting points, different y-intercepts, different constants. So that's why on number two, it would just be no solution, which is choice A. Okay, let's scroll down a little bit. Look at number 3 and 4. So number 3, you have these two terms here circled in red. You want to combine those like terms first. 5v minus 2v gives you 3v. Then on the right-hand side, you want to use distributive property. Multiply, get rid of those parentheses. And you get 3v minus 6. Then you're going to combine those two terms here that you see in blue, or in teal now, it's lighting up. So negative 6 plus 13 gives you the positive 7. And unlike number 2, you still have the same slope, same coefficient of 3. But this time you have the same exact constant, or y-intercept, which is positive 7. Now you can actually stop here at this point, since you see that the expression on the left is equal to the one on the right. So now that they're equal to each other, it's the same exact thing. Now they are infinite. So this would be infinitely many solutions, which is choice D. Scroll down a little. I know I'm going through it a little bit quick, but again, you can play, pause, and rewind at your convenience on this video. All right, number 4, we have Marcus and Kevin. Gives you a little bit information about their rates that they charge as landscapers. It gives you this information here for Marcus. His expression would be 20x plus 150, and Kevin would be 35x. So to figure out how long it would take for their cost to be the same, remember same means equal, so you simply want to set both expressions equal to each other. 20x plus 150 equals 35x. When you solve it, you'll get 10, so it would take 10 hours for both of their rates to be the same, to be equal. All right, heading down into number 5. Number 5, we just had to take this standard form here, 9x plus 3y equals 12, and we had to convert to slope-intercept form. So remember, you're going to isolate the y, so get rid of the x term, and then divide by the coefficient for y. And you're going to get y equals negative 3x plus 4, which is choice B. And the last two that I worked out for you here, I didn't work out all the problems. It's not all of them needed to be worked out. But number 7 is this one with the graph here. And it gave you the black line there, which was y equals 1/2 x minus 4. And then the question said, um, which equation represents the line shown? Actually, sorry, I'm looking at the wrong one. Sorry, this is number 8. Sorry, number 8, which is here. So it gave you the black line, which is y equals 1/2 x minus 4. And the question is asking you, if you had to graph another line, y equals negative x plus 2, what would be the solution? So if you look, I've actually graphed it for you in blue. I even labeled it so you see what that line would look like. And if you look in red, I drew a circle identifying the solution. So both lines would meet right there at that point, which is positive 4, negative 2. And that's choice D. Last but not least, let's go down to the last one that I worked out for you, was number 9. Number 9, kind of the same idea. This time it did graph both lines for you. You see on the left, y equals 3x. On the right, y equals negative x plus 4. And it's asking the same exact thing. What would the solution set be? So in other words, where would both lines intersect or meet or touch each other? And that's here at this ordered pair that I identified in red with the circle. And that would be positive 1, positive, well, I wrote 1, 4. It should actually be 1, 3. That's my mistake. So positive 1 and positive 3. So actually, let's go in now. See, teachers make mistakes as well. It's okay. Let's delete that. And that should actually be positive 1, positive 3. See, that's why it pays to double check your work. But that's it for now. If you have any questions, rewatch the video or send me a message. All right, thanks. Make sure you study. Catch you later.